Hey everybody, welcome to video 3-2, and in this section, in this lesson, we're going to be talking about how we determine if figures on the coordinate plane are congruent or not. And so remember, the word congruent is a word that means the same. And so if we have an inkling as we're looking at a image and a pre-image, or two figures that are on the same coordinate plane, what we want to do is, if we have an inkling that they look the same, then we have to be able to come up with a way that one got transformed onto the other. Okay, and that needs to be a rigid motion if it's going to be congruent. So remember, rigid motion is the same thing as either a translation, that's the sliding, a reflection, that's the flipping, or a rotation. Those are the three types of rigid motion. So if you can do one of those three things, or even a combination of those three things, and get one figure to land onto the other, then you know that the two figures are congruent. Okay? In this section, it's gonna, whenever it says explain your answer or justify that they're congruent, it's going to be asking you for coordinate notation. So you want to make sure that you're referring to the rules that we've kind of worked through here in the last module, module 2. So I'm just going to write here that those rules for all those transformations can be found on pages 66, 76, and 90, and that goes in the same order that we were just discussing the transformations. So if you're looking for a translation rule, that's page 66. If you're looking for a reflection rule, that's page 76, and the rotation rules are on page 90. Remember also that we summarized this in a Google Doc for you that is linked off of your outline, so keep that in mind, okay? So let's look at example 1, part A together. These two figures, it looks like we have two quadrilaterals on the coordinate plane here, and we have an inkling that they look pretty much the same. So what we're going to do is we're going to try to find a rigid transformation, one of the three over here, that will map one onto the other. Mapping is basically means that it's going to move from one to the other, okay? What we can do is we can take C, D, E, F, and notice it's kind of flipped over. So what we need to do is identify, what did it flip over? Well, it flipped over the y-axis, is that line of reflection. So what we need to do is write in coordinate notation the rule for flipping it over the y-axis, and that's xy gets transformed to negative xy. So the x coordinate just changes sign. And if you look at just a couple of points, let's say point F was negative 4, 8, and then that gets mapped onto point M, which is positive 4, 8, so that makes sense. In part B, we have two triangles. We're trying to see whether they're congruent or not. So we are going to look at them just very briefly and say, yeah, you know what, they appear to be the same. So we're going to see what maps onto what. Well, triangle ABC maps, it looks like, to XYZ, and the order of this statement is really important, so let's take a look at that for a second. First off, A is given in, it's given in alphabetical order, but in the second triangle, we want to know what point does A appear to get mapped to. Well, A is like the right angle corner of that triangle, so we want to map it to the right angle corner of the new triangle. So that's going to be A to X, and then B is that top corner there, which gets mapped to Y, and then C is this left corner, and that gets mapped to Z. So it's important that you know the order of these letters is significant, okay? So the question is, which one of these rigid transformations is it that moves ABC to XYZ, okay? Well, clearly it changed its position, and its position looks like it also turned. So we're going to say that this was a rotation rotating it somehow, and seeing as we are across one axis down here, the positive x-axis, and then it turned to be across the positive y-axis, it looks like that's just a one quadrant turn. So that's just going to be rotating it 90 degrees. And remember, if we don't specify, that's of course assumed to be counterclockwise. So a rotation is a rigid motion, and that is going to prove that the two figures are congruent. If we wanted to write the coordinate notation for this, we're just going to look at page 90, remember, and we're going to say that the original xy point gets transformed to negative y comma x is the rule for a rotation of 90 degrees. Let's just double check that really quickly. If we take one point, let's say point C here, which is 4, -2, 4, -2 to begin with would become, C gets mapped, as we said, to Z, which is the point 2, +4. So the question is, did that rule get followed? XY not only changed places, which we did here, but we changed the sign of the y coordinate from negative to positive. So yes, that is following the rule. So we know we are all set with that one. So next on this page, I want you guys to go through and identify what rigid motion, if the two figures appear to be congruent, identify what rigid motion would map one onto the other, okay? And so we're going to be looking for going from the black to gray, because remember, the gray is the image and black is the pre-image. Black is where we start, gray is where we end up. So how did we get from one to the other is the question, okay? So take a pause in the video and answer those quick your turns for me, and we'll move on. Okay, continuing here. Sometimes it takes more than one rigid motion that will map a figure onto another. And of course, there might be a couple of different ways of going about it, depending on what you do first. So just keep in mind that as long as they're all rigid motions, if you kind of line one right up after another, it's still going to produce a congruent figure, okay? So in part A here, it says the figures are shown to be congruent, or excuse me, the figures shown are congruent. So you know that to begin with. What you are trying to figure out is not are they congruent, but how are they able to be mapped from one to another. And remember, we're going to go from the black to the gray, okay? So we're going to try to manipulate in part A here this triangle so that it gets moved over somehow and mapped or reflected or rotated to be onto this triangle, okay? And of course, in order to justify it, we're still giving the coordinate notation. So remember, those are the rules on page 66, 76, and 90 if you want to look at the coordinates, or on our Google Doc, okay? All right, so for part A, we want to map triangle ABC onto PQR, and we can do that by merely rotating 180 degrees around the origin. So let's just follow one point through that process. Let's start with point C. If we rotated C 180 degrees around the origin, it would move from -2, -2 is C, to the next spot it would land would be +2, +2, because the rule for the rotation is just to change the sign, remember, of each of the coordinates. And then if we landed there, let's zoom in just a little bit. So we're rotating from C here up to this point, but notice we still are not quite where R is. We want to make sure that we move from C slightly to the right, and it looks like just 1 unit to the right. So from after the rotation, we want to translate just 1 more unit to the right, and a right motion is of course going to modify the x coordinate. So this is our sequence of rigid motions, and that proves that ABC can get mapped to PQR. Let's do another one. In part B here, we're trying to map ABCD to JKLM. And again, let's follow just one point. Okay, so let's say we find, and we're moving from A to J. A is going to start out at the point +3, 4. And let's see how we can get that to where it needs to be. Well, it looks like to me it needs to slide down, okay? So we're going to map it first with a translation, because we want to slide that point A down to where J is, and so that is a movement of, counting on the grid here, 2, 4, 6, 8, 10 down. So our translation first is going to be leave x alone, but move down 10. And then once that's there, it looks like we need to also do a reflection. And it's not, I don't think, as simple as just a reflection over the y-axis. So we're going to zoom in here really quickly and try to figure out where that line of reflection is going to go through, and we will see what we can do there. So the reflection is going to be over, if we zoom in here, remember the line of reflection is at the midpoint. So if we want to find the midpoint of these 2 points, where J is and where A has gotten slid down to, we can find the midpoint of the point J, which is at -1, -6, and A, or A prime if you will, after that first translation, which is at 3, -6. The midpoint of those is going to get mapped to -1 plus 3 over 2 and -6 plus -6 all over 2, or +2 over 2, which is 1, and the next one is -12 over 2, which is still -6. So the point 1, -6, or right here, is where that line of reflection is going to get drawn through. Okay, and we know this is a nice vertical segment right here, KJ, and so is AB once it gets mapped down there. So it should be pretty straightforward to just know that all of those midpoints are going to be right on that line. And so that is over the line. The vertical line, x equals 1. If you write the equation of the line that you are reflecting it over, if it's not an axis, then that becomes a little tricky to write the coordinate notation for it. So just know that this is sufficient, okay, writing what is the equation of the line that it's reflected over. And we found it because we found the midpoint of the image and pre-image, if you will. So once you know the equation of the line, that's enough. Okay, you don't need to worry about what goes in that second blank. So again, guys, just a reminder that you could have done this sequence of rigid motions in different ways. Okay, maybe you chose to do the reflection part first, in which case all you would need to do is a simple translation down to where your final point would be, but it's up to you, okay? So long as I can follow your work, and as long as your work is shown and it's correct, it's fine, okay? More than one way to skin this cat, if you will. All right, at the bottom of this page, you have your your turns for tonight, which is 5 and 6 that I'd like for you to attempt, and see if you can write coordinate notation for the transformations that you are using, okay? In general, if you see that a reflection and a translation needs to happen, if you do the reflection first, then the translation can always kind of be modified to get you where you need to go. I kind of did it in reverse just so that you could see if you were to do it where the translation was done first, like I did for part B, then the reflection might be over something other than an axis. So just keep that in mind. All right, we'll see you next time.